All right, so the ideal gas law, again, is in order for us to figure out moles when we are not at STP. All right, so the equation is that PV equals nRT. So let's define what the variables are. P is pressure, V is volume, and it's important to note that the volume has to be in liters. N is the number of moles of a gas, and T is the temperature in Kelvin. So again, I mentioned before that it's a good habit that we make sure that whenever we're doing a gas law problem that we convert it to Kelvin from Celsius. All right, lastly, there's the R, which is the gas constant. And this is located on your reference tables. Now, if you notice up here, I didn't have a specific unit for pressure. And we know that pressure can be atmospheres, it can be pascals, or it can be in millimeters of mercury. So if you notice on the front of your reference table, there's actually 3 different gas constants listed. So, and you can see them here. So if you look in the unit for the gas constant, so it's kind of this big messy unit, but you notice that it's got liters, and it's got moles, and it's got Kelvin, but then it also has a pressure unit. So this would be the gas constant that we would use if we had kilopascals, so it would be 8.31. If we were given the pressure in millimeters of mercury, then we would use this, which was 62.4. And if we were given the pressure in atmospheres, we would use this one, which is 0.0821. So we allow our pressure unit to determine which gas constant that we use. All right, so let's just do one quick example. So it says, what volume will 2 moles of nitrogen dioxide occupy at 300 Kelvin and 90 kilopascals? So we have PV equals nRT. So my pressure is kilopascals, which is 90, times the V, the volume, which I'm trying to solve for. I have 2 moles of gas. And if you notice, I've got 8.31 here. Let me just click back up. You can see that the gas constant that has kPa, kilopascals, in it is 8.31. So that's why I selected that R value. And then the T, temperature, is already in Kelvin, so it's 300 K. So if I were just to divide by this 90 on both sides, I would get 2 times 8.3 times 300 divided by 90, which gives me a volume of 55.4 liters. So again, this just adds in one other element of moles, as well as identifying this gas constant based on the pressure unit.